I'm pleased to introduce our second and final panel for today's meeting. I'm going to start by introducing the moderator, and then I'll let him take over in terms of introductions for the panelists. But I've been really looking forward to this panel. We have a terrific lineup to talk about the topic of advanced technologies and the implications and issues surrounding transmission with those. For our moderator, we have Peter Behr, who's a senior energy reporter with E&E News. Peter covers areas such as power grid reliability, climate policy, and cybersecurity. Peter's been a long-standing friend of WIRE's and has been involved with our organization off and on quite a bit over the past few years. So, Peter, really pleased to have you here, and I'll let you go ahead and kick off the panel.
Okay, thank you, Larry. Is this volume about right? Yes. You can. Okay, so welcome to the second panel this morning, and we're fortunate to have three experts to talk to us about grid-enhancing technologies that are going to have the capability of increasing the capacity of the grid and addressing the need for more renewable power and the need to replace a lot of power lines in the country that are at or past their lifetimes. So we have Jay Caspary, who's sitting next to me here, who's a senior consultant with DOE after a long career with SPP and writing a couple of hundred reports for grid strategies. And, next to him is Terron Hill, who's the Clean Energy Director for National Grid. And National Grid has jumped out into a leadership position in employing some of the clean energy technologies that we're talking about this morning, not only acquiring them and installing them, but also as an investor in them through its really unusual partnership program, venture capital program. And last is Bill White with CTC Global, who is the Director of Business Development for the for the Northeast. Bill?
Yes.
Yeah. And CTC Global, as I'm sure you know, is a leader in the development and installation of advanced high voltage cables that, because they have a carbon fiber center that's much lighter than the steel centers that are the common transmission line design, they can put more aluminum on it and carry more current. So it has the potential to increase the capacity of the grid through reconductoring projects. And Bill's going to talk about some of the projects they've done and some of the regulatory issues that they run into. And I guess let's maybe start, Terron, with you, if we could, to describe what National Grid is doing, particularly in New York State and in using some of the advanced technologies for grid capacity that are out there now.
Sure, thank you. Can everyone hear me? But first, thanks for inviting me here today. It's exciting to talk about the work that National Grid's been doing. When you think about our industry, it's really an amazing time to be here in our industry. I mean, how often do you get people that really want to know, hey, what do you do and how do we make it better? I remember when I first started at National Grid, I would tell my friends, my family, that I work in transmission. They would be like, what is transmission? You work in cars? But now when they see me, they're like, hey, when are we going to get more transmission? Because everyone is thinking about how do you really advance forward this energy future. When you think about the states that National Grid operates in, we operate in states that have very aggressive goals when it comes to clean energy. And when you think about those goals, I was just having a conversation, are you going to be able to make those goals? Well, I'm not sure, but we're trying our best to make those goals. When you think about how much we're investing in renewables, when I first started National Grid, we had, not excluding hydro, less than 1% of wind and solar on our networks. Now in New England, we have over 10%. And when you look at New York is advancing forward quite aggressively. By 2030, 70% renewables by 2030. And that goal is actually achievable when you think about it. But it's only achievable if you have the right transmission network in order to make it happen. Our states, the federal government, DOE, everyone's recognizing that you can't just do renewables by itself. You actually have to deliver that renewables to load. And so that requires us to invest in transmission. You look at those numbers, we're seeing today we invest roughly $30 billion. We're going to have to triple that actually in the future. And when we start thinking at National Grid, how do we make that happen? How do we make that happen and still allow bills to be affordable at the end of the day? We have more in transmission than we can actually spend capital on at the end of the day. We operate in one of the oldest parts of the country. There's a ton of asset condition work that has to happen. And so when you think about how do you really optimize the existing asset that you have, that's why we start to look at advanced technologies. We need to see how can we really take the assets that we have, recognizing that it can take 3 to 10 years to build transmission. So what are technologies that you could deploy today in order to be that are much quicker, that you can deploy much less capital, while you're still waiting to get those investments forward, because you still need those investments. So a lot of times people ask, oh, well, National Grid, why are you looking at things like dynamic line ratings? Doesn't that take away from your rate base? Actually, at the end of the day, we have to do both. We have to invest in transmission, and we have to invest in things like DLR, power flow technologies, digital substations. All of this is needed in order to create that more dynamic grid. When you think about EVs, our load is really going to go up with electrification. Right now, when we look at our forecast, we're seeing that by 2035, in New England, we're going to have a winter peaking system because of electrification of transport, because of electrification of heat. And so all of this stuff means that we have to think smarter, differently about how we invest in our networks. So for us, this is really a no-brainer. We look at technologies, we think about how does it make us operate our systems with more flexibility, more resiliency? How does it make us be able to spend our customers' dollars more wisely? And so when you think about what we've done in New York, last week we just announced one of the largest deployments of dynamic line ratings with line vision. And that deployment is unique and is bold because we're not only just installing a few devices, but in Western New York, we installed devices and we fully integrate those devices into our energy management system, into our EMS, which means that we're changing the ratings in real time. And that's having an effect on our markets, and it's also unbottling wind generation in that area that will allow us the time such that the existing wind that's already there can get to load and can have a price reduction on the LMPs, on energy prices, but it's also given us that time that we can rebuild the network out there to address things like asset condition, resiliency, and the increase in loads that we expect. So for us, this is really about how do we make sure that we're ready, that we're future-proofing our networks, and that we're thinking bold about how do we actually meet the aggressive climate change agenda that we have before us.
Okay, Terron, thank you. Before we get too far into this, Jay, maybe you could take a second and just in case people aren't fully up to that, explain the kind of where we are in this line rating debate. We have static line ratings, which are used throughout the industry, with a couple of exceptions. PJM and ERCOT use something called ambient standards. And as Terron just said, National Grid is jumping ahead with dynamic line ratings. Could you, just for the benefit of people that don't deal with that, what are we talking about here?
Yeah, thanks, Peter, and thanks to Larry and everybody for inviting me to come back to Wires. It's been a while, and it's great to see some old friends and make new acquaintances. Dynamic line ratings have been around for a long time. The technology has been proven, especially in other jurisdictions, not necessarily in the U.S. like it could be. But you know, how we plan and operate the power system to a large extent is based on pretty conservative assumptions about how much ampacity you can push down a conductor during summer peak conditions, you know, and rightfully so. Those assumptions were pretty conservative in terms of the ambient temperature, the wind speed, and things like that that actually drive the maximum sag on a conductor in a span, which is driven by safety and the life. You want to keep these assets up in the air for a long time because you spend a lot of money on infrastructure. Like you said, Peter, ERCOT and PJM and some others are using ambient adjusted ratings and actually dynamic line ratings on certain facilities. It used to be a research project, and now it's actually becoming part of the market operations in New York. And I know that in PJM, PPL and Duquesne are actually deploying dynamic line ratings on key market efficiency constraints that they've seen over the years.
So the key difference between ambient and dynamic ratings.
Yeah, is basically taking full advantage of the actual environmental conditions, right? And wind has a huge impact on how much ampacity you can push through a line before it sags. So especially in the wind-rich regions of the U.S., where I was at Southwest Power Pool for 20 years, we knew that if the wind turbines were turning, that there was significantly higher wind speeds in that vicinity than what was being assumed, in a planning study or in an operations model, which might be just 2 feet per second or something. The wind would actually be howling at 20, 30 miles an hour out there, and clearly there was more headroom on that wire before you'd get into safety issues or reliability problems.
So FERC has directed transmission providers to use ambient standards, which are essentially updated weather forecasts, but they don't take into account temperature of the air, the wind speed, the temperature of the conductor, and these other factors that would all go into a dynamic line rating, right?
Yeah, that's true. The ambient adjusted ratings typically just reflect, they make an assumption about wind speed, obviously, but they reflect the actual or forecasted ambient conditions. No, it's driven primarily by wind speed, or not wind speed, but by ambient temperature, which is pretty easy to forecast. And you can look up tables and see how much current you can push through a conductor at 60 degrees versus 100 degrees, and make that adjustment in your market models and in your reliability studies.
Thank you. Let's go down to Bill and talk about another technology, and that is advanced conductors that your company manufactures and sells.
Thanks a lot, Peter, and thanks to Larry and everybody else here, and great to be on the panel with Terron and Jay, and in the room with so many people I work with. And first of all, I want to express my regrets of my colleague David Townley, who couldn't be here, so I'm sitting here in David's place. He had a death in the family and couldn't be here. So, but I'm glad to be able to fill in for David. Great discussion. As Peter said, we make an advanced technology, high capacity, low sag conductor. Our conductor is called ACCC. It uses a carbon fiber composite core. I think I showed this to you, and probably all of you have one in your bag or on your desk somewhere from one of us. But there are a number of different technologies in this space. Ours is one, using the carbon fiber. There are other materials that are used. Just to give you a sense, it's an advanced technology. It's also proven. It's not particularly new. We started installing it in 2005. We have 120,000 kilometers installed in 1,100 projects worldwide in 65 countries. We've done everything from 11 kV to 1,000 kV. So, we've done a lot of work, and it's an established technology, but it's a technology that's displacing a technology that's been used for more than 100 years, the steel core aluminum conductor, ACSR. So, it's a process. The benefits, about double the capacity for the same size wire, less thermal sag, and cutting line losses by up to 30%. So those are really significant benefits. But first I want to talk about, I'm on the business development side now. I've done a lot of work in policy, and I'll talk a little bit about how our interactions with customers go today. So why do people choose our wire today? And there are basically two kinds of projects that we win. And one is a project where we can provide a technical solution that no other technology can provide. And a great example of that is American Electric Power. Back in 2016, they completed a project that won the Edison Electric Project of the Year, Edison Award. It was a reconductoring of 240 circuit miles of a 345 kV line in Corpus Christi. The Texas Commission said to AEP, you have to double the capacity you have to use the same structures, and you can't take the line out of service. So that was a pretty tough request. Fortunately, our technology was able to double the capacity on the existing structures, and with some help from folks at Quanta who did a really terrific job with energized reconductoring, it became the largest energized reconductoring project completed in the world up to that point. So we were really proud to be a part of that project, and it was very successful, completed ahead of schedule, and provided tremendous line loss savings and other benefits to all the consumers of electricity in Texas. More recently, we worked with National Grid in 2019. They had a really tough, much smaller project, but a tough project in southeastern Massachusetts, where they were faced with the daunting prospect of replacing 95-year-old lattice towers in a very, very tight area, which would have been incredibly difficult and prohibitively expensive to do. We were able to give them the capacity they needed, achieve the required clearances they needed, again, in cooperation with another company, AmpJack, which was able to raise some of the towers a few feet, reinforce the foundations with micropiles, and in conjunction with our technology, able to provide a solution that was much faster and much cheaper than would otherwise have been achieved. And what I want to say, just in closing to this part, and bring another example up later, hopefully, what these projects have in common is that the solution that used our technology was less expensive upfront, and it had a lower first project cost than all of the alternatives, or it was just simply technically impossible to do it with any other way. And it didn't necessarily justify the use of the technology, our advanced technology, or any of the advanced technologies, based on the benefits of those technologies. Those really weren't taken into consideration. They were there, obviously they existed, and they were delivered, but it wasn't, so what we are looking forward to in the future is the prospect of utilities being able to use advanced technologies, even if they have to spend a little more upfront, recognizing the very large benefits that will come in over time, whether they're capacity, line loss savings, reliability, or other benefits. And I think the language in the FERC NOPR is specifying exactly the kinds of benefits that we've been talking about, and a lot of people in this room have been talking about for a long time. So we're looking forward to that, and I have one example I want to share on that point.
So, Bill, for people who aren't familiar with it, how much more expensive is it?
Yeah, so our wire, size for size, so same diameter wire, we have about 30%, 28% more aluminum on the same diameter. That's going to be about 2x. Roughly, so somewhere between 1.5 or a little over 2, something like that. But conservatively, I'd say 2x. It's come down recently because we've seen much lower multiples lately, just because steel supply has been affected dramatically, especially by the war in Ukraine, and so steel prices have gone up a lot, and steel lead times are much longer than they used to be, and the carbon lead times have not been as similarly affected by that particular constraint. But over time, we expect it's already starting to change, but so we'll see back to around roughly 2x.
Jay, let me ask you for an overview. So we've heard two technologies that have a lot of pluses in them. How fast are these technologies making it into the U.S. grid? And what are some of the key obstacles that are in the way right now?
Sure, but before I do that, I want to expand the horizon a little bit, because there are additional things we can consider to help us take full advantage of the existing system. I don't know if you've heard of a principle called NOVA that I think originated in Germany, but it's basically, let's take full advantage of existing assets and infrastructure before we start considering upgrades to new stuff or to right-sizing new stuff, because it's so difficult to build new transmission lines. But anyway, there are other things besides advanced conductors or dynamic line ratings that I like to keep in my toolkit when I'm considering how to optimize the current system, and things like topology optimization and control. We see that being used for operations today just to keep the lights on. But what I think the big advantage for that is to reconfigure the system, and think of it as a Waze or a GPS system for the power system, just like you use to get from here out to Reagan Airport. You know, the best path may not be the direct line that you typically take because of an accident or something else. It may be quicker for you to go somewhere else to get there and go around about. And that's what New Grid's technology will do. Will help you identify quickly potential configurations of the system that actually lets you take advantage of latent capacity on the system that you can't use because of the current network design. I think that has tremendous value as we start looking at long outages to rebuild existing infrastructure or other things that are going to happen to the system, where you can actually see that coming, you know, 6 months out, and you can deploy this technology as a way to reconfigure the system during that outage and help manage congestion. Congestion on the power systems doubled or tripled in the last year or two. And I don't see any end in sight as we start adding more and more renewables, because we can't add infrastructure fast enough, new lines. The other technology that I like to talk about a little bit is advanced power flow controllers. You know, we've used phase shifters or phase angle regulators forever on the bulk power system to manage flows. These are more modular devices that can be redeployed and actually are being used on the UK National Grid system today to actually add impedance or lower impedance to the system to redirect the flows, okay, without actually switching operations, but just adjusting the impedance. Those are two other technologies. Some people like to consider storage as transmission as a grid enhancing technology, or superconductors and things like that. These technologies, you know, are just starting to get deployed, and I'm excited to see that. I think there's huge promise. They've been deployed more in Europe than here in the US. I think that's driven by incentives and business models and financial reasons. But I think if we're going to get to deep decarbonization quickly on this grid, we've got to use these technologies quickly and find ways to do it. You know, we're just taking advantage of sensors and algorithms and hardware that's been out there and used in different ways. We just didn't deploy it on the power system. And by doing so, we can actually have better information about the actual conditions of the power system. Because with static ratings and things like that, we're kind of flying blind. We really don't know how much conductor you know, how much ampacity you can put on a line, or what the opportunities are, unless you look at those. But grid operators have been doing that for decades. They know how to keep the lights on when it comes to reliability, but I think there's some huge economic opportunities to use grid enhancing technologies.
But are there some specific practices and regulations that are inhibiting some of these new technologies? For example, Bill brought up one, for example, and that is, can you really count the long-term benefits from capacity improvements as an upfront cost? This is an industry that has caught hell for gold plating from time to time when they've been accused of overbuilding facilities that aren't needed. Jay, what are the important obstacles in the way things are done and the way decisions are made that currently stand in the way of some of these new technologies?
That's a great question. I don't know if I've ever seen a transmission facility that's been overbuilt or gold plated. You know, the market will adjust and take full advantage of the capacity on the system. Maybe not to the extent it could be if you use new sensors, new technology, new approaches. But I don't know. I'd like to hear comments from the others on that, if you don't mind.
Anybody else want to jump in on the question of kind of obstacles in the way projects are evaluated?
Yeah, I think it's, you know, something we talk about a lot. Our product provides efficiency benefits that aren't typically recognized. So I'll give you, so first I just want to say, you know, what I would say about our technology applies to many technologies. There are benefits out there, so, you know, I speak from experience of our technology. And then the rates of change, I think we're recognized. We heard it all day here that, you know, the rates of change on the system due to, you know, the changes on the demand side and the supply side happening simultaneously really, you know, changing the expectation that the likely error is not gold plating, the likely error is underbuilding. So I think there's been a massive shift in that direction over the last 10 years, certainly, and even faster in the last few years. So I'll give you one example. We've talked to the Vermont Electric Power Company recently. They had a project to upgrade a 115 kV line, the K42 line, and back in, they started out thinking they were going to use, and I'll just get a little wonky here, 1351 ACSR, single bundled conductor, one conductor per phase. Pretty good capacity, pretty big wire for a 115 kV line. They redesigned it. They decided that it would be better to lean in the direction of building in more capacity for a bunch of reasons, for line loss savings, for the anticipated changes in terms of this is in a corridor that is going to be used to import a lot of renewables from Canada and New York. So they went back to the drawing board and they redesigned the line to use double bundled, so 2 conductors per phase of 1272. So they went from 1 1351 to 2 1272, essentially doubling the capacity of the line. They had to make the structures a little more robust. They had to spend a little more money. Bottom line, they ended up spending roughly $6 million more, which amounted to about a 12% increase in the budget. They went over to the ISO New England Planning Advisory Committee, a bit nervous, understandably, I think. I won't speak for them. You can talk to them. And really found almost unanimous approval in the committee for what they were proposing to do. And that was memorialized in a letter from the ISO. A few months later, NESCO, the New England Council, the governor's analog to the ISO for the 6 New England states, came in and said, wrote a letter to the ISO and said, this is great, this is right sizing, we want to see more of this. We would recommend that the ISO take this right sizing approach and look at benefits for all future projects, whether they're delivering renewables, whether they're addressing reliability issues, or their asset condition projects. So really develop a process to institutionalize this kind of an evaluation.
Were you surprised at that green light?
The whole thing was kind of surprising to me. Because I don't think it's ever been done in exactly that way. I mean, I think, as we know, we have SPP, Highway Byway, we have MISO MVP, we've had broader processes that are looking at a specific set of projects that have a broad evaluation, but I think to apply it project by project in this way and count the benefits and say, we're going to spend a little more on this project to get these benefits, and that's how we're going to square it. That's new in my view. I mean, I'm happy to hear that everybody's doing it, but I'm pretty sure these guys are the first ones to do it.
Are you running into, though, kind of a real world problem of trying to bring competition into regions that don't necessarily want it? And have a chance to say something about that.
Yeah.
In the way projects are evaluated.
So I'm aware that
this was a case where the incumbent said, "Yeah, please come in and do this," but that's unusual.
Right, and I think that again they didn't pick our wire to do this. I wish they had, but they didn't. They did it on their own. But I think the principle would apply to our technology and many others who would say, we will add a little more cost up front. And we'll give you a lot of benefits that offset that cost very quickly over time. And I think that's the principle that's very interesting to us to see illustrated. I think that's going to apply very broadly to a lot of advanced technologies. And frankly, in my experience, and I would let the customers in the room respond on their own, to say that, it's always been a barrier to adopting new technologies if the initial cost is higher. In this space. So that's always been a significant barrier to doing that. But if you can justify that cost with the benefits, then you can accelerate the penetration of these technologies on the system.
Terron, I wanted to come back to you and dynamic line ratings and look back at the FERC record that of comments by the industry. And there was a big pushback against FERC's proposed rulemaking on ambient rulings from Edison Electric Institute and some of the transmission providers. And they raised a couple of questions. One was that the amount of data that is going to come streaming into operators from all of these sensor readings it could be a burden, and they're concerned also about the more things that you strap onto the grid, the more surfaces for cyber attack. How did National Grid satisfy itself about the risks of going to dynamic line ratings and managing those much more complex computer calculations that you have to make to run the thing, moment by moment?
So two things. I'm going to answer your question, but I do want to get back to right size in just a second, because I feel that I think there's a misnomer when we hear, oh, utilities just want to gold plate because you want to increase your rate base. When you think about the 1970s and 80s, where we were seeing huge increases in AC demand, it was driving up load quite a bit. Utilities were investing in their networks in order to handle that amount of air conditioning load. A lot of that air conditioning load didn't actually materialize, though, at the end of the day, when you go back and look at the history. But that capacity was still used. And it's because of that capacity that was built into the system that those first movers, generators, were able to connect to the system at lower costs. And we really need to actually employ that type of framework today. When you think about what is the impediment to renewables, it usually isn't capital, it's not the developer. It can be the queue, but the panel talked about that before, but it's usually transmission. And because it takes so much longer for transmission to get built. So we really need to start moving away from a let's size it for the reliability need today. We need to start to right size for what is that need tomorrow, such that we can get those renewables that are expected on the grid, as well as address other issues. So that's the first block there. I want to answer your question now. To the second question, I don't want to come up here and say that National Grid has thought this all out. I mean, my job is to be a cheerleader for these type of technologies, because we see it as really serving a good value for our customers. But it wasn't easy when we first started to introduce this strategy at National Grid. I remember meeting with leaders at National Grid, such as Brian, our CEO over there, and saying, hey, we should be doing these technologies. But when we met with the teams, the people on the ground who had to maintain these assets, had to think about restoration during outages and emergencies. When you talk to the more technical, really people that get in the weeds, that like, what's inside this box? How is it going to, like, how are our protection schemes and relay schemes going to work? There was a lot to figure out. When you start to import more and more power electronics on the grid, more things that are more dynamic, like there's a reason why we like things static on the grid. When you think about what is our number one job as an industry, it is to keep the lights on in a safe manner. And you do that by minimizing your risks in the network, not by increasing it. And when you have more and more information, when you have more and more dynamics that are going on, you're increasing risk just by design. We understood that very well at National Grid. So we didn't actually just start deploying this stuff all over the place. We did some pilots. And we brought in the Department of Energy. Idaho National Labs helped us with cybersecurity. They gave us a lot of tips around, where do you put these DLR boxes? How high up do they need to be? Where do you put stuff inside the fence kind of thing? And then we started thinking about our communication backbone. Like, how do you make sure that these things aren't hacked, like they're hack-proof at the end of the day? So there's a lot that goes into it. It's a lot that goes into when you think about having objects in the grid that during a storm response, you have to actually maintain it. There were cases where we had linemen pass by DLR boxes and be like, wait, call it in. There's something, that's not supposed to be there. So there's a lot of educating on the field. There's a lot of bringing people from the field to see these deployments. We actually worked hand in hand with our vendors in making sure that it wasn't our vendors installing this stuff, but it was actually National Grid staff that was taken forward, that was National Grid staff involved in every single element of the cycle, such that we had to become familiar with it and such that we could start to think about how do we replicate it. So when we think about technology at National Grid, we don't just do pilots to do pilots. We don't just adopt technologies without fully testing them, but we always look at, if we're going to do this, is it something that we can do widespread deployment of? Is it something that we can standardize? Because that's how you get rid of risk. And is it something that is repeatable at the end of the day?
How willing has National Grid been to share the details of what you learned from these pilots so they become pilots for the
Definitely.
whole
So-
industry.
So with things like digital substations, for example, we've created a digital substation working group that some of your utilities have probably attended meetings. We just had a meeting back in Syracuse just last month. And this is all about sharing, because at the end of the day, we're not the only ones that operate transmission assets. Many of you in the room, you work for transmission companies. There's a lot that we can learn. And we need to collaborate. We need to be, within the industry, we need to talk to one another in order for us to not repeat the same mistakes. So if I made a mistake, I actually want to share it with you. And that when you think about some of the impediments to deploying these technologies, it's actually getting regulators and policymakers in the room to say, hey, we are going to make mistakes. We can't just be fine, because if you have that kind of structure where it's like just slap you on the hand when you make a mistake, then we're not going to be willing. And I think that's been part of the impediment that you've seen from the utilities, because going back to whether it should be ambient temperature or dynamic, well, we have NERC requirements. And our NERC requirement says that, hey, that rating that's in the system better be correct, because lives are at stake if it's not correct, and you get fined if it's not correct. And so dynamic line ratings adds a whole new dimension to that. And NERC has been willing to have that conversation, which is helpful, and that's why we're seeing the industry move forward.
Jay, do you think that pilots are effective throughout the industry, because each of the transmission operators, the operators of the system, are responsible for protecting their system? So if someone else did it, if Terron's company does it successfully, how persuasive is that to the rest of the industry that, yeah, okay, we can go do this? Is there kind of a not invented here problem that
Sure. Clearly, that's an issue in the industry, right? And every system's different. The conditions and the resource mix and the weather patterns are all different, and each utility, each grid operator has to make sure that what they're trying to, or what they see in New York on a pilot actually is meaningful to the wheat fields of Kansas, right? And the good thing is, I think there are forums. EPRI will help with that. The U.S. government can help with grants, and they've done that in the past with ERCOT, for example, and actually, deploying PMUs or employing dynamic line ratings to see how they would actually affect grid operations and planning, mostly operations and markets, right, in the near term. But there's also, like the North American Transmission Forum, there's ways to share these experiences and try to educate other people about the opportunities to use some of this technology on your own system. But I think everybody's going to have a pilot here or a research, R&D project somewhere else on their system to get comfortable with it, so that, like Terron said, you're not going to deploy it unless people are comfortable with it and are confident that it's actually going to improve operations and not become an impediment.
So the number one reason that you might be optimistic that some of these new technologies will accelerate would be what? And what's your number one reason that you might be pessimistic? What's your good news and bad news?
Let me start. I'm really impressed with what's going on at FERC with the NOPRs, encouraging transmission providers to consider the actual use and deployment of grid enhancing technologies in generation interconnection studies and planning studies. I think that's really important. We've also got to, the impediment is always change, right? And it's hard to convince people to do something they're not comfortable with. So there's a lot of education that we've got to do here about these technologies and where are the best places to deploy them. Some of the challenges, I think, are when you do broad scale orders, ambient adjusted ratings being deployed on every line may not make a lot of sense. In dynamic line ratings, you probably should focus on the 10 or 15 flow gates that you have that have been persistent problems and the ones you expect in the next 6 months, 12 months out. But it probably doesn't make sense to deploy that, across the board. So we've got to be smart in allocating our time and resources to find ways to actually improve the performance of the grid.
Before we go to questions, I'd like to go back to something, Bill, that you and Terron talked about, and that is that, Terron, you pointed out that New York State is really pushing the utilities to advance into clean energy. And you pointed out, Bill, that Vermont welcomed your project. Does that suggest to you that we're going to see different rates in which states adopt and really get interested in these next round of technologies and what they can do? And what's the consequence of that for the grid that operates in these, two multi-state interconnections plus Texas? Question number one is, do you think this is really going to be going to vary state by state, and what are the possible consequences of that?
I'll try to start on that one. Yeah, it's going to vary state by state. It already is. So our biggest U.S. customer right now is Southern California Edison, and by far, and it's Southern California. So they see a lot of problems before the rest of the country, and so they have a unique combination of rapid deployment of renewables, electrification of transportation. They have a lot of load growth because they have population growth in the region. So they have all these things happening very quickly at the same time. So the constraints that they have a lot of environmental constraints on siting, maybe the most severe constraints in the entire country. So all of these things together, really favor a technology like ours, which can solve a lot of those problems in ways that other technologies can't. And so that's one reason why I think it was Scott from MISO who said, every part of the country is different, and so we all are facing different circumstances. I think we have some similarities in the electrification of end uses. They're happening at different rates. So I think the need for these technologies is going to be across the board. It's going to proceed a little differently in every region. Bottom line, though, I think what's common is this recognition of benefits and costs, and recognizing that if you're going to make 50-year investments, if you can, add a large amount of capacity on a 50-year investment for pennies on the dollar today, it really doesn't make sense not to do that. And if you can add that efficiency and that capacity for pennies on the dollar, which is the case with the technologies today, with our technology and others, it just, looking at the magnitude of the challenges that we're facing in this industry over the next several decades, to me, it's kind of a no-brainer that you do it. And so I think that would apply pretty universally. And as Jay said, people are going to figure out how to use that network capacity over time.
Yeah.
Your thoughts on that, Terron?
I completely agree. And at the end of the day, all transmission is local. When you think about what's happening at the local, the state level, and within communities, if there is a need to increase capacity, if there's a need to do it smarter, if there's a need to do it, in some cases, more expensive, but better benefits, that's what really drives that technology to go forward. So what is that need at that location? You see it happening in California because of all the challenges they have, not just with the increasing electrification, but with wildfires and other things. I've noticed there's a technology that we start using from Connectrix that they start using. We learned it from talking to them. When they're using it we're using it for asset management purposes and being able to see what the condition of the conductor is. But they're using it for wildfires, actually. And it's the same technology. And it's and that's part of the reason why we have to talk to one another, because it's like, you're using it for this use case, but actually we have a use case that's different, but the technology applies the same. And we can use the lessons learned from how you're deploying on the network for how we're going to deploy on the network. But it's also just thinking about, what are your states asking for? What are your communities asking for? In the Northeast, our communities are asking us, they're demanding of us to push that renewable and clean energy future forward. And so we're trying to figure out, how do we do it at the most affordable way possible?
Thank you. Could we have questions from the audience?
Thank you. David Strobridge from ITC. We've talked about AARs, DLRs, advanced conductors. I can't help but ask, what's next? Is there anything in the R&D hopper that you guys are really bullish on in the coming years?
Go ahead. So one of the innovations that we recently added to our wire is we put optical fibers inside of our core. Right now, those optical fibers are being used to verify the integrity of the core from manufacture all the way through dead ending and installation, so you can check that nothing was damaged inside the core all the way through the process. Future applications for optical fibers inside the core include monitoring of a lot of characteristics of the wire. So we look forward to that. That's a few years down the road, but we think there are a lot of exciting opportunities with these new materials and these new designs that of things we can do down the road with this technology.
Any other questions?
Well, while we're waiting for a question, actually, we have one. Go for it.
Yeah, good afternoon. I'm Tom Moore from Surveying and Mapping, SAM. But I've got a background. I'm retired from Southern Company for 40 years, so a little bit of knowledge about transmission and other parts of the business. In our meeting in Nashville, we talked a lot. We actually had a panel that talked about the electric car initiatives, fast charging network, some of the things that are going on, and that process has been moving along fairly rapidly. Recently, the states made submittals to DOT on their state plans for electrification, in particular the fast charging network component of that, and those plans have now been reviewed by DOT and are in the process of being returned back to the states for implementation. My question has to do with the impact on the grid, and it's got to be different everywhere. Obviously, MISO will have a different impact than National Grid, and Southern Company's grid impacts will be different from others. But my question to this panel, and we spoke a little bit before the panel came up, is how are the grids planning for this? How are the large IOUs and others getting ready to support what could be a significant increase in distribution margin impacts as well as transmission margin impacts, and are we ready for it? And I guess more fundamentally, strategically, what's the right way to pursue this? Because it appears that there's a chance to get the cart before the horse. The DOT side is moving with light speed. At some point in time, they're going to hit a wall unless something's done on the grid side of this to determine how we're going to do this. So I apologize for asking a loaded question, but I'd be interested to see what you think about that. Thank you.
So first, I think is a great question. I think you must know that National Grid, we've just been looking just at this issue right now. And when we think about the EV future is something that is coming, regardless if people think is going to happen or not. When you look at the forecast, just reading an article by Bloomfield New Energy Finance, and articles going back looking at their older forecasts, and what they found is that all their forecasts were always wrong. It was always double the amount of EVs on the road than what they forecasted would be on the road. And we're just going to keep seeing this happen. As you see the OEMs, Ford, GM, all change over their supply chain mixes, this is where you're not going to have the option. It's going to be like people who loved incandescent light bulb, and so they hate it when we came out LED. Well, you can't buy an incandescent anymore, or if you can, it's very expensive. It's going to be the same thing with EVs. And so this is something that we at National Grid said, hey, we need to prepare for now. We need to start thinking about what does this look like on our networks. So we did a study first looking at fleets, and you actually can find that study today, where we looked at just one location on our network, because what you find is for fleets, they tend to be in the same area right off the highway. Makes sense, right? You get cheap land, you locate industrial stuff all together. And what you found is that when fleets start clustering together, the loads become very high, and your feeder system, just the feeder capacity gets eaten up very quickly. We're finding the same thing with highways, so we'll be releasing a highway study fairly soon as well. And this study is going to be public, and we're going to show you what we found looking at the types of vehicles, the technology advancement, looking at how consumers are likely to charge. 350 kW type chargers and above, that we're actually very conservative. We're only looking at 350 kW charging. And actually technology is going to advance much forward faster than that. You're going to see megawatt charging. And you're seeing that at gas stations that are, or fuel plazas today that are gas stations, they're not connected to sub-transmission or transmission. They're connected to distribution. National Grid's in a great place because it just so happens our transmission network overlaps the major highways quite well. And so what we're starting to think about is how do you start to connect up these highway sites with sub-transmission and transmission, because it could actually be cheaper to do that when you think about going back to what is the right sizing. So do you start to put in the distribution upgrades just to get 3, 4, 5 chargers, or do you start to put in the sub-T upgrades to get 20, 30 chargers? Because that's what's going to happen. It could be cheaper, actually, when we look at the cost economics. Instead of going in every time the customer calls us up and say, hey, we're installing more chargers, can you come back out? It can be better to right size it up front, and that way you can also get through with the permitting challenge and do this stuff all at once, than to just go back in and out. But my main message here is that it's coming, and as an industry, we have to be ready, and so that's why we did these highway studies.
I agree, but just to add a little bit to that, that's all great. I just think our industry needs to be more proactive, okay? And we need to identify where the optimal location for big fleet, locations are. They may have nothing to do with the criteria that the fleet operators use today, okay? There's transmission hosting capacity, tools and things that EPRI have developed and industries using that could identify the best places for that. And the other thing I think is, there's going to be huge price signals here, I think, that are hopefully going to drive actual demand and the needs to upgrade the system. I'm a big fan of getting the right price signals to people and to aggregators, and that they could be part of the solution long term and help us increase the asset utilization overall and lower total cost to delivered kilowatt hours if we do it right. So I think those are both important.
Bill, you've got the last word.
Okay, so just to add from our business perspective at CTC Global to what Terron was saying about the low voltage system. So, we've focused on transmission for our history at CTC Global, transmission applications of our wire. We didn't think the value proposition was really very good for the low voltage system. We started getting our customers in India actually were the ones who first pressed us to develop low voltage solutions because of the severe overloads on the low voltage systems across many parts of India. We went ahead and started developing low voltage, smaller wire sizes and low voltage applications of hardware and so forth. Started introducing those just last year, and lo and behold, around the same time, our U.S. customers started saying, we need to look at low voltage applications of advanced conductors because we need to add capacity and efficiency on the low voltage system. Again, starting where else? In California, but really moving all over the country pretty quickly and seeing, just as you said, that the loads increasing very rapidly on the low voltage system, upgrades of substations going up all over the place, really actually being rolled into charger development plans. They're rolling in substation upgrades just like wind developers rolled in transmission upgrades into wind development projects. So we're seeing that happening, and the wires are going to have to get upgraded as well. So I think it's a terrific question, and I think the market is responding now, but there's a lot more work to be done.
We've got a couple minutes. Larry, how much time do we have?
We have time for one more question, which I'm going to ask.
Sorry, folks.
So you've mentioned some of the different programs that are out there, either grant programs that are already underway and being implemented. You've talked about some of the FERC proposals that are underway. My question to each one of you is, if we could hand you the regulatory magic wand, and you could direct one thing for regulators or policymakers to do that would be most impactful for getting into play advanced technologies or grid enhancing technologies, what's that one thing that's not being done or not being proposed that you think should be done?
Let me start. That's a great question. I think incentives are really important. The way that the grid's been built and costs have been recovered historically may not be the right model going forward. And if we would incentivize and find a way to share the benefits and the savings of these technologies, so that it's just not the transmission owner that's bearing the cost and the risk. And if other people are benefiting, then find a way to share some of that benefit and cost allocation. It's complicated. but we've got to find a way to crack that nut.
That is a slight twist on your response. Because I think when people hear incentives, they say, oh, you just want more money for your shareholders. And I think we have to look at it differently. So in the UK, they have a model called REAL. And REAL is basically an incentive structure, but it's actually looking at the needs of the system quite differently in order to consider benefits more broadly. So when you think about the US regulatory regime, it is very much centered around reliability. What do you need to do in order to keep the system reliable? And we have compliance mandates, and we have metrics for how we determine that. But what we don't do, especially those of us that operate in organized markets, where the transmission mix actually has a huge effect on the prices that customers pay, we don't actually build our system in order to ensure the most efficient wholesale prices. And so I would encourage regulators to think about how do we change the needs case such that if customers are paying for not just reliability, but they're also paying for inefficiencies in the market, that transmission owners are actually incentivized in order to create a more incentive wholesale market. And you see this in the UK. So when we refer back to power flow controllers and smart wires, the whole reason why our UK business, National Grid Electric Transmission, went forward with smart wires is because they had an incentive in order to reduce the congestion between Scotland and England. And so that's the reason why they deployed that technology, because they were able to share in those benefits. So the customers got the majority of the benefits, but 10% of those benefits went back to the utility.
Benefits, count the benefits, do it consistently, and allow utilities to really create a space. I think that's happening, but maybe we need to be a bit more explicit about it, RTO by RTO. Go ahead, add capacity, spend a little more, and again, incrementally create that space. Not saying, double the cost of a project or something like that, but we know there are technologies well within the, single-digit percentage increases in cost that can make dramatic differences in the performance and dramatically improve the benefit-cost ratio of that project. And we're kind of nickel and diming it in a way that we're missing those opportunities, and we lock in, think of it as locking in inefficiency and locking in constraints, because that's what you're doing when you make those decisions.
Yeah, Larry, it just seems to me that we're witnessing this fascinating and really important conflict between the drive that technology gives to opportunism and innovation, because people see opportunities, and the status quo. And in this industry, a lot of that is based on the need for reliability and security and to keep the lights on. And so these two things are going to collide. And ultimately, I guess it's a political decision. Thanks, everybody. Thanks, our panel. Please give them a round of applause. Time for lunch.
Well, I want to thank this panel and all of our speakers from earlier today. I think we had a really interesting and great program, and thank everybody for being here. We do have lunch available, so please feel free to take advantage of that. And thanks everybody for being here. We'll call it a wrap.
That went well. Thank you.